Have you ever wondered what could happen if a massive asteroid like Apophis came dangerously close to Earth? NASA has confirmed that this dreaded asteroid will make a return in 2029, and its impact could lead to global catastrophe, including tsunamis, forest fires, and earthquakes. But how can we effectively defend against such a colossal threat? What are NASA's plans to prevent a disaster? And what measures are being taken to protect our planet? The threat of the asteroid has a name that is as dramatic as its potential threat. Named after the ancient Egyptian legend of chaos and destruction, Apophis first caught our attention in 2004 when it triggered a major asteroid alarm. This enormous space rock, about 340 meters wide, seemed to be heading straight for Earth. Scientists were alarmed by the idea of such a massive asteroid possibly crashing into our planet, which could level entire cities, cause massive land fires, and even trigger huge tsunamis. The disaster potential was so great that it could lead to global catastrophe and regional crop failures. Luckily, in 2029, Apophis will pass by us, but it's going to come closer than any of our geostationary satellites, just barely missing us. And it will come back. This asteroid orbits near Earth and will cross our path again in the future. While there's a chance of an impact down the line, 2029 will be a crucial year for scientists. It will give them a rare chance to study Apophis up close and gather important data about asteroids. To help with this, the OSIRIS-APEX probe is on its way to Apophis. This spacecraft, which previously explored the asteroid Bennu with great success, is now equipped with new technology to study Apophis. By analyzing samples from these asteroids, scientists hope to learn more about their composition and density. This knowledge is essential if we want to develop strategies to protect Earth from future asteroid threats. Right now, we have one main plan for defending Earth from asteroids: pushing them off their orbit. NASA's DART mission proved this is possible by successfully shifting the small asteroid Didymos from its original path around a larger asteroid. So, what exactly do we know about Apophis? Thankfully, we don't have to wait until 2029 to learn more, because scientists are already studying this potentially dangerous asteroid. Recent observations have shown that Apophis is much more complex than we initially thought. High-resolution images and detailed analyses have uncovered a variety of surface compositions, raising new questions about its geological history. These variations might hint at processes happening on the asteroid, but what exactly occurs on an asteroid is still a mystery. Apophis and other asteroids, which likely formed early in the solar system's history, are not only fascinating to scientists, but also important for our future. Researchers have combined radar and optical observations to map Apophis's orbit with greater accuracy. This improved data helps estimate the chances of a future impact with Earth. One interesting finding is that the Apophis's orbit is affected by the Yarkovsky effect, which is caused by the way an asteroid heats up and cools down unevenly. Although the chance of Apophis hitting Earth in the next 100 years is low, the long-term risk remains a concern. Future research and advanced probes could make it easier to defend against such threats. Understanding gravitational interactions and the Yarkovsky effect is crucial for refining our impact predictions and preparing for potential future asteroid impacts. Who would have guessed that studying asteroids could lead to such technological advancements on Earth? The need to understand Apophis and other asteroids has driven the development of cutting-edge technology, including the OSIRIS probe, advanced telescopes, new instruments for asteroid analysis, and innovative computer models for simulating asteroid orbits. Observing asteroids is challenging because these space rocks are often dark and small. Most telescopes are designed for bright objects like stars and nebulae, capturing light to create images. But asteroids can be nearly invisible, absorbing most of the sunlight that hits them. The new James Space Telescope is designed to overcome this problem and can track asteroids close to Earth. NASA has ambitious plans for the future. After the OSIRIS-APEX mission, there will be additional missions to study Apophis more closely. These will involve advanced landers and orbiter probes that will closely monitor the asteroid. These missions will gather detailed data on Apophis's surface and internal structure, and some may even return samples to Earth. Exploring the interior of an asteroid will offer us unprecedented insights into these near-Earth objects. The fact that we can now defend against asteroids highlights our technological progress. This global effort to protect Earth brings nations together, showcasing impressive international cooperation. The European Space Agency, or ESA, and the Japanese Space Agency, or JAXA, will contribute to these missions, and even more collaborative efforts are expected. The creation of defenses against prospective asteroid impacts is a crucial component of future study. Tests of impactors that can divert an asteroid from its orbit are necessary, as is the development of new strategies for emergency asteroid deflection. Every country has something to offer, and it's only if we're united that we can even do this. Scientists and engineers from certain countries are developing lander probes and drilling technology, while others are providing much-needed funding or software for modeling programs. Permanent observation of Apophis with large telescopes will be necessary for long-term monitoring. And here too, experts from several countries are collaborating around the clock. Could studying Apophis bring us closer to discovering extraterrestrial life? While the threat of asteroids is serious, their exploration could also lead to exciting breakthroughs in understanding the origins of life and the search for life beyond Earth. Asteroids like Apophis are considered time capsules from the early solar system. They've preserved organic compounds and prebiotic molecules from billions of years ago. For example, samples from the asteroid Bennu revealed a range of amino acids which are essential for life. If these amino acids were found on a planet like Mars, it would be a strong indicator of past or present life. But finding them on asteroids raises intriguing questions. How did they get there? When did they form? And what does this mean for the origins of life on Earth? Amino acids and organic molecules don't just appear out of nowhere. Studying Apophis could help us understand the processes that create these life-building blocks and whether similar processes might occur on other celestial bodies. By examining Apophis's surface geological features and the effects of space conditions, scientists can develop models to explore the potential for life in extreme environments. Asteroid research is a fascinating intersection of astronomy, geology, and biology. While Bennu didn't provide direct evidence of life, it offered crucial building blocks. The exploration of Apophis could reveal even more about the conditions necessary for life, expanding our understanding of how life might emerge elsewhere in the universe. So how was Apophis formed? The wonderful thing about asteroids like Apophis is that they formed in the early days of our solar system. They're most likely the remains of the dust and gas clouds that gave rise to our sun and planets, and they have probably altered very little since the solar system's inception. Near-Earth asteroids such as Bennu and Apophis circle the sun on a course that frequently intersects with our planet. As a result, asteroids do not target us while they are on a collision track, but rather approach Earth's orbit when they are on their own, generally extremely erratic orbits around the sun. An impact would not be a malicious strike from space, it would just be a foolish coincidence. So what do you think about Apophis? Does it hold some keys to the beginning of our universe? And what can it tell us about the emergence of life in other parts of space? Let us know what you think down below, and don't forget to like and subscribe.